All right, welcome to one more session of your WC students. Yes, one day before the exam. Welcome back. Today we are going to do the part 5 and the final part of your term 2 examination. Yes, what is it? Let me tell you before I show you the most important thing. Nothing to worry, students. All the best. Yes, today I'm going to send you one more video, very important video about. Yes, that's also a secret. Let me tell you, at night I'm going to send you one more video. Before that, without wasting time, always remember you are always going to self motivate yourself. Yes, keep telling yourself that I am the best, I am the best, I am the best. I tell that, whenever I stand in front of the mirror, I tell myself, I am the best, I am the best, I am the best. What will happen? Because of that, you get that confidence, self confidence on you. Okay, right. Let us start off the session. Let us not waste time. Time is very less for us. Wait for one more video in the night. Yes, very important video. Now, this is a target. I have to hit this target, correct? Let's start off. So, basically, we are going to write important. We are going to learn complete trends in D and F block elements. Yes, I'm going to show you practice questions also. I'm going to explain you the reason also. Very important. We are going to learn different concepts like, electrode potential questions we are going to solve. We are going to solve questions based on your color property. We are going to solve questions based on your atomic radii and ionic radii. I'm going to show you concepts like ionization potential, oxidation, basically different oxidation values. Yes, all these questions I'm going to solve, and many more in this, many more than this. Let's start off the session. Right. So first important thing before we start, go through the video completely. My request, please subscribe to the channel, like the channel, and like the video also. Sorry, share the video and comment. Why? Because we are going to start with a NEET series. Now, NEET series is going to start off, students, very soon. So please join the platform. Vani ma'am is going to provide you free and quality education. Got it? Okay, let us not waste time anymore and let us jump into the concept. Right. First thing. So whenever you are learning D and F block elements, basically actinoids is deleted and your KMnO4 and potassium dichromate is not there. So what is not there, students? Actinoids is not there for you. Potassium permanganate preparations and properties, potassium dichromate preparations and properties are deleted. Done. Apart from that, what is important? Let's see the trends carefully one after the other. Right. So basically in your board examination, you'll be getting a graphical based question. So they'll give you a question based on the graph. They will ask you questions 1, 2, 3 like that. So gradually we will learn. I'll tell you the tips also. The first important thing, students, among your D block rather than the F block elements, remember if they ask you about hardness, careful, remember students, hardness question if it is asked, what is that depending upon? Hardness is directly proportional to the metallic bond strength. Remember students, what is it? Metallic bond strength. Okay, ma'am, metallic bond strength is dependent upon what? It is directly dependent upon number of unpaired electrons. Okay, number of unpaired electrons are increasing means your metallic strength increases, so your hardness also increases. For example, if I take my 3D series or the D series rather, check carefully. Chromium has D5 configuration, molybdenum, tungsten, they are very hard. They're very hard. Why they are very hard? Because they have half-filled configuration because of the unpaired electrons present in them. So they're very hard. Like that, remember zinc, cadmium, mercury are not very hard because why not very hard? Why they are not very hard? Because they have paired electrons. Unpaired electrons are there means less hardness because they will not form strong metallic bonds. No strong metallic bonds. No strong metallic bonds. That's why they are soft in nature. Then comes what, students? Mercury. Mercury is soft. It is very soft and it is a liquid and it is having the weakest metallic bonds. So the examiner or they ask you, remember these reasons. So unpaired electrons more means hardness more, paired electrons more means they are very soft. This is about the hardness. Next trend, we are going to learn about melting and boiling point. Check carefully, students. In melting and boiling point, this is a graph which is given to you. So what to remember and what clue to remember? Remember the tip. What is that? The tip is, remember, melting point and boiling point are directly related to your metallic bond strength. Okay, right. Now, just now, metallic bond strength. Just now, what did I say? The metallic bond strength depends upon the number of unpaired electrons. Say, na? So, unpaired electron increases means melting and boiling point increases. Why? Metallic bond is strong, na? Yes. So, for unpaired electrons, they can comfortably form bonds with the non-metals, and the metallic bond is very strong in them. Done, students? Okay. Now, what to remember in the graph? Remember, students, melting and boiling point, if I see the graph, what is happening? It increases from top to bottom, right? What is the first thing? Melting and boiling point, if I see in a group, yeah, it increases from top to bottom. Okay, top to bottom. This is one trend which you should remember. Okay, done. Except, there's always exceptions, except in 2B and 3B. Remember, except in 2B and 1B, it is not increasing because of your contractions in that. So, the size, carefully remember. What is it to remember? Yes, tungsten has more MP and BP than molybdenum, more than chromium. This is the question they will ask. Copper is more than silver, is more than AU. Reason I just now told you. So among these, which is having low? Zinc. One is cadmium, one is mercury, have very low, means comparatively low melting point. Why low melting point? Why then other D block elements? The reason is other than other D block elements. This is what is the reason they're going to ask you. What is the reason, students? Only one reason. The reason for this is, yes, they have completely filled. Yeah, very good, rightly said. They have completely filled n-1 d orbitals. Correct? They completely filled n-1 d orbitals. Correct? So what will happen because of this completely filled? There is covalent bond formation. They're not expected to form covalent bond among themselves. They have to first form a covalent bond. So no covalent bond among themselves. No covalent bond among themselves. So because of this, among themselves. So because of this, they are themselves. Because of this, the only thing, zinc, cadmium, mercury has very less BP and MP. Done. So whichever have half 3d5 series unpaired electrons, d5, 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 5, 5, 5, for them it is nothing but they are strong metallic bonding and they have more melting point and boiling point. Next question, easy, yaad kar lo. They're going to ask you these three only. Then comes atomic radii. Okay, atomic radii, what to remember? Yes. See the trend. If I take a 3D series, this is here. Check here. From scandium till your scandium, titanium, vanadium, everything. What is happening in the atomic radii? From left to right in the periodic table, the atomic radii is, okay, left to right. What is going to happen if you check? Normally in grade 10 we have studied the atomic radii decreases because the electron enters into the same shell. But there are a lot of variations in D block elements. What is that? So in a period, remember students, careful. Yes, 3B is, okay, come when you go to 6B, okay, when you go to 7B, all right, when you go to 8B, all right, then when you come to 1B and when you come to 2B, you know what a B is, right? You've already studied. So what happens? Here, from here till here, the decrease in size, whatever size is there, the decrease in size, okay, it will be a constant value. From this one to this one, it will be a constant value. Done. Slowly, this follows this flows. From 8B, remember students, there is slight increase. There is slight increase in your size. What is the reason? Remember, first of all, why is this happening? So the reason here is, careful students, when I check 1A and 2A, sorry, 1A and 2B orbitals, okay, when I'm checking here, there are electrons in the d orbitals, correct? So what will happen in this case? Electron repulsions occur. There are electrons, more electrons, electron repulsions increases. So because of this, what will happen, students? Z effective decreases. Z effective decreases. So when the Z effective decreases, automatically what will happen? The size starts increasing, na? Yes, the size starts increasing gradually. Yes, the size starts increasing gradually from there. So that's the reason. So you can write the reason and do it. Now let us see the reason in a group. Okay, very important thing. Check carefully what to remember. So normally before I start with the group, carefully understand, students. Yes, two things. First I'll tell you what you should remember in the group. Before this, in the particular period, it was like this. Now there is one concept called, what is that? Lanthanide contraction. You remember, students? Yes, I have 2 pages to write. I will write that. So when you start in the group, there is a concept you are going to talk in terms of lanthanide contraction. Okay, so lanthanide contraction. So what is this? Because of this lanthanide contraction, careful, what is a hint or what is a tip you should remember, students? Remember ionic size of cations. Okay, ionic size of cations with which one? With same oxidation number. With same oxidation number decreases in a period. Okay, once again I'm writing whatever ionic size of the cation with same oxidation number decreases in period. Okay, decreases in period by increasing atomic number. Okay, what is the story, ma'am? I didn't understand this. Check this. Suppose in the exam they give you, let me take one example. Okay, right. So what did I say? Increase in the size, ionic size of the cation with same oxidation number. You only see Ti plus 2 is more in size, ionic radii. Then V plus 2. Are you able to see? All are there. Okay, titanium, vanadium, chromium, manganese, iron, cobalt, atomic number is increasing. But what is important? Oxidation numbers are same. So ionic radii of cation with increase in oxidation number decreases in a period. By increasing means atomic number is increasing. Oxidation number should be same and it decreases down the group. Yes, because Z effective is increasing. So vanadium is less, chromium is plus 2, manganese is plus 2, iron is plus 2, cobalt is plus 2, yes, nickel is plus 2, remember, and copper last. Got it, students? So this size is very, very big, ionic radii compared to that. And one more thing you have to remember is, yes, suppose if they give you different ions, okay, now same ions you said. So different cations they have given. So what should you remember, students? The order goes like this. Ti is there, Ti plus 2 larger size, Ti plus 3 larger size, Ti plus 4 larger size. Then comes iridium plus 2. Next one more we'll write. Copper plus 3, copper plus 4, copper plus 5, then copper plus 1, then copper plus 2, etc. Now, what is the reason for this? Remember, what is the reason means? What is the reason? The reason for this is, check carefully, as oxidation number, okay, are different. So, oxidation numbers are different in which one? They're different in, for different ions, correct? For different ions, or ionic sizes. So this oxidation number are different for different ionic size cations. What to remember? Yes, as the oxidation number is different and the ionic rays for different ions rather, so the oxidation number increases. That means, what is understanding? As you move, as a particular element has different oxidation numbers, Ti has a Ti plus 2, Ti plus 3, Ti plus 4, like this. If it has among them the oxidation number, careful, it is going to have maximum as you increase the oxidation number. So oxidation number increases with decrease in ionic size. Ionic size decreases as the oxidation number increases. So what is the concept? So Ti4 is a smaller ion compared to Ti4 is a larger ion compared to your Ti plus 2. Got it, students? So what is important? As the ionic size reduces, oxidation number increases. Done. So careful. So remember, let me erase this. If it is confusing you, I'll take this out. So what to remember? Check the order. So Ti plus 2 is greater than Ts3. What should I remember? Once again, I'm summarizing. I should remember, careful, when oxidation numbers are different. In the exam paper, if they give you different oxidation numbers, what should you remember? One thing. Ionic size or ionic radii decreases as oxidation number increases. Is it okay? Yes. Is it okay, students? Right. So why did I write like that? Because I said na in decreasing order. So that is what I have written. Next important clue. Next important before we start the trend and ionization potential. One more thing to remember. Careful. Suppose if you take this in a group only, what is observed in the group? Top to bottom, you're observing lanthanide contraction. Lanthanide contraction. So lanthanide contraction, because of that, lanthanum ion has having more than yttrium, then scandium plus 3. Got it, students? So 4D series, 5D, same group cations will have same ionic radii. Got it? So in a group, what to remember, students? 4D series, 5D series cations, they will have same ionic radii. Because of which one? Because of lanthanide contraction. Done? Chalo. So this is about this. Don't get confused. The order is given here. Note it. Chalo. Next important thing, ionization enthalpy. So ionization enthalpy curve graph is given to you. So what to remember? Carefully from the graph, important points I will tell. So in a period, when I go from in a period, what will happen from left to right? Left to right, basically there is slow increase in IP. See this, it is increasing, it is decreasing, it is increasing, slow. So IP values are increasing slowly. Okay. Why? What is the problem here? Yes. Here important thing, careful. With less energy, I can pull out the electron. Done. Why? The reason here is Z effective is decreasing because shielding effect of shielding effect of n minus 1d electrons. Because of this ionization values are like slowly. So slowly up and down you are having it. Done. What is the order for this? Careful. Once again, I'm having this slide. So for the ionization potential, what is the curve? What is the order, students? You should remember vanadium is less than chromium, less than manganese, less than iron, less than cobalt, less than nickel, less than copper, less than zinc. So the reason I have given, yes. So this is having more ionization enthalpy because of paired electrons, and the Z effective is that is a trend for your IP. Trend in IP, ionization potential. Okay, students, remember this. So ionic radii, atomic radii, ionization potential done. Next reason, oxidation states. Remember. So basically, oxidation states, when I check, careful, scandium has, these are the stable oxidation states, stable. Scandium is going to show two types of oxidation state, +2 and +3. Vanadium is going to show me 0, +2 to +2 to +5. Done. Zinc stable oxidation state is +2. Okay. Then titanium, it is +2, +3, +4 and +5. Okay. Done. Chromium, if you take 0, +1 to +6. D5 is most stable. Cadmium +2 only. Done. Now check. Among all these, the highest oxidation state is shown by whom, students? It is shown by ruthenium and osmium. Remember, ruthenium, how much is oxidation state? +8. Osmium oxidation state is also +8. In which case, in example, if I see in this case, Ru4 +8. Osmium OSO4 +8. So the oxidation states are shown by different oxidation state. Why, students? Due to large number of unpaired electrons. Point number 1. Second important thing, they have The energy level difference between n minus 1d and ns are almost nearby. The energy level difference gap is there, no? The gap is very less. When the gap is very less, you can take out the electron from ns and n minus 1d also. That's so one more important thing, very important slide. Remember what to remember. What is it? Check carefully, students. Covalent character or covalent nature is directly related to your oxidation number. What is this? How to remember this example? Check. What is this? Suppose oxidation number is more, means it is more covalent. See this VCl4. This is more covalent, by the oxidation number is +4 and compared to VCl3. Correct. Compared to VCl2. Done, students. This is ionic. This is more covalent. If I have to compare. One more reason, carefully understand. Acidic character is directly related to your oxidation number. So one more important tip you should remember. For example, let us take one example like this. Let us take one example. See this, students. Vanadium is there, VO. Okay. Oxidation number very less. V2O3 is there. VO2 is there. V2O5 is there. Now tell me, whose oxidation number is more? This one. So this will be basic in nature because it is less oxidation number. Then comes V2O5. This also is basic. Then comes VO2. Oh, this is amphoteric oxide. This is amphoteric oxide. Then comes V2O5. This is acidic because its oxidation number is maximum. Na? That is what we have written. Next important thing which you should remember, students. Yes, one more I'll give you example. Say this. MnO, Mn3O4, Mn2O3, MnO2, MnO3, Mn2O7. Now you only tell me, students, Mn2O7. Tell me which one. See this. These are, this is less. This oxidation state is maximum. So Mn2O7 is a strongly acidic in nature. It is very strongly acidic. Yeah. So MnO is basic in nature. Done. MnO2 and MnO3 are amphoteric in nature. So they will act as both acidic and basic. Got it, students? So remember the trend. Acidic character is directly proportional to the oxidation number. Point number 1. Covalent character is directly proportional to the oxidation number. Point number 2. Done, students? Easy? Remember. Next characteristic property is complex formation of D and F block. They will ask you, why are they forming complexes? The reason which you are going to give is, remember, here cations, whatever are there, the metal cations, they have high effective charge, high Z effect, right? And the cations are small in size. Okay, done. When the cations are small in size, what will happen? They will have high positive charge density, correct? No? Positive charge density will be high. Charge density is high. So what will they do? They will accept lone pair of electrons. Done. They will accept lone pair of electrons from where? Lone pair of electrons from where? From ligands. They're going to take electrons from the ligands. Done. So when they are taking electrons from the ligands, what will happen? They form complexes. So that is the reason why D block are going to form complexes. Let us take certain examples. K4FeCN6. See this. This is the ligand in this case. This will donate electrons to this. NiCN4 taken -2. This is a ligand. This is going to donate electrons. Yes. CONH3 taken 6 times. See this, how many ligands are there? +3. This is donating, this is taking. That's why, because of the small cation size, they're going to form complexes. Done, students? Easy. Next. Standard reduction potentials and reducing property. Very important concept. We are going to do these questions also now. Check carefully. So, important thing, observe carefully. Whenever somebody talks about E naught, electrode potential values, check carefully. You will write your answer based on first heat of hydration. Heat of hydration. Remember this. Second, electrode potential depends upon heat of sublimation. Done. Electrode potential depends upon heat of ionization. Done. So you are going to talk in terms of these only. Perfect. Now let us solve some questions and say which is oxidizing, which is reducing and everything. Let us start with questions and see and done. First question, which of the following forms colorless solutions in aqueous medium? Oh, when they ask you color property, color question or colorless question, remember one thing students, more number of unpaired electrons. How will you find unpaired electrons? You will write the configuration and check. More number of unpaired electrons. See this. You write the configuration, atomic number is given. Write the configuration, take out 3 electrons and see. More number of unpaired electrons, more colored they are. Yes. Here in this case, more number of paired electrons. If they are paired like zinc, yeah, cadmium, mercury, if they are paired electrons, it is colorless in nature. That's why zinc is also white in color. Got it? So when I check scandium plus 3, scandium 3 electrons, there are no, after taking the configuration 21, I wrote, and I took out 3 electrons, I'm getting argon configuration here. That's why this is filled and automatically this is colorless. So this is color. We have to judge like that. Next question. Which of the following ion is most stable in aqueous solution? How to decide this? Remember, I said something na? Oxidation state. So electronic number is given to you. Write the electronic configuration. Take out 3 electrons. After taking out 3 electrons, if I check, first write electronic configuration. Then take out 3 electrons minus 3 electrons. You will get one more configuration, deconfiguration. So when you check that, Cr plus 3 is, check whether it is having D5 configuration. So D5 is stable. Correct. So D10 also is stable. If you have T2G step also, that T2G, if you have D3 configuration in T2G, suppose if you're getting D3, then also it's stable. So in this case, chromium is most stable. Check with the configuration. Most stable in aqueous solution. Check in the table. Done. Next, slowly let us go into the question one more. The basic character of transition metal monoxides follows. Okay, how to decide this? Remember students, basic character when somebody asks you what is the rule. Yes. So basic character of monoxides. These are all monoxides now. Yes. So remember, basic character of monoxide decreases with as atomic number increases. Atomic number increases. Yaad kar lo. This is the tip here. Basic character decreases with as the atomic number increases. Now, according to the atomic number, which one students? Which one? Second option, TiO more than vanadium, more than chromium, more than. Yes. So, iron is basically 26 atomic number. So, atomic number is increasing means basic character decreases. Atomic number more, basic character decreases. Yaad kar lo. Done. Sure. Next question. Among the following series of transition metal atoms, the ion where all the metal ions have D2 configuration. D2 configuration. So basically they have given this question, they are asking you to find out D2. So what will you do? You will take the atomic number, write the electronic configuration, then whichever ion is there, check. Titanium plus 1, take out 1 electron from here and write the configuration. Like that, V plus 4, take out 4 electrons from the configuration, then find out. D6, take out 6 electrons from here and check. Manganese plus 7, take out 7 electrons from here and check. So whichever gets D2, that is called that ion they're asking you. So normally when I check all these configurations, remember Ti plus 2, V plus 3, Cr plus 4 and Mn plus 5. Yes. these ions have D2 configuration. You only check, students, these cations have D2 configuration. Sorry, 3D2 configuration. You only check. They have total of 20 electrons they will have. You only check. So you have to check like that. Next question. Which of the following lanthanoid ions is diamagnetic? Okay. Atomic number is given to me. I have to check which is diamagnetic. What to do? Take separately. Cerium plus 2 is given. What is the atomic number? Write the atomic number. Then what will you do? Check for the electronic configuration from that. Perfect. After checking the electronic configuration, suppose, let us assume, in case 1, I am getting in cerium Sn plus 2, Eu plus 2 and Yb plus 2. Check first case. Yes, I am getting, after writing the configuration, here N is equal to 2. Here N I got 6 unpaired electrons. Here Ni got 7. Here Ni got 0. So you only tell me 2 electrons means singly filled, na? Singly filled, it is paramagnetic. Done. Yes. Then comes, they're asking you which is dia. Now in this case N is equal to 6. So 1, 2, 3, T2G, 4, 5, 6. There are 4 unpaired electrons. This is also paramagnetic. Here N is equal to 7. Again 1, 2, 3, 4, 5, 6, 7. Again unpaired electrons are there, paramagnetic. Here N is equal to 0. So it is all filled. So it is diamagnetic. So you are going to check the question like this. Done, students? Done. Easy. Next question. Which of the following ions is the most stable in aqueous solution? Okay. Again the same story. Earlier we did the same question. No? So what should you do? Chromium plus 3. Why? Yes, I told na. Write the electronic configuration. I did this question earlier. Take out 3 electrons and check what configuration you're getting. If D, you get D5 configuration. If you get D3 in T2G, like this also, they are stable in nature. Done. Ciao. Next question. Account for the following. With the same d orbital d4 configuration, Cr plus 2 is reducing while Mn plus 3 is oxidizing. Remember, students, careful. So for chromium or manganese question is very important. Check. So basically Cr plus 2 is reducing means what is it? What is it actually? Is it donating electrons or accepting electrons? Remember, first you should check their configuration. When you take such questions, please try to check. From Cr plus 3, it is gaining 1 electron and becoming Cr plus 2 in aqueous solution. Yes, aqueous solution. So, because of its gaining electrons, observe the electrode potential of this is negative, minus 0.41 volts. It's gain. Done. Now check Mn plus 2 in aqueous solution. Done. Taking 1 electron, it is becoming Mn plus 2. This is also an aqueous solution. Electrode potential value is plus 1.55 volts. Now tell me. The negative value of this, what is it, students? It is SRP. It is strongly reducing. Done. This is your positive value of this. It means it is strongly oxidizing. Ma'am, how will I know the electrode potential value? I can't remember. No? So you can do one thing. You can write the configuration from which one to which one it is going. It's going to from D4 to D5. From this one also you check configuration. By taking it is going to the next configuration. By releasing it is going. With that you can easily say that. Okay, students. So check with the configurations. Check if it is going from D4 to D5. If it is reaching a stable configuration, it will tend to lose 1 electron. Yes, if it is going from, check, if it is going from, like, if I have to say the particular configuration, like it has to come. If it is from D4, if it comes to D3, if it is losing means it will lose 1 electron. Correct. If it gains some electron means basically it will check whether losing is better or gaining is better. Done. So based on that, reducing activity and oxidizing activity. Next question. How will you account for the following? Yes, the oxidizing power of oxo anions. Careful, students. Very important. Yes, very important. Oxidizing power of oxo anions. These are all oxo anions, metal and oxygen, metal and oxygen, metal and oxygen. Remember, careful what to remember. In case of Cr2O7 minus 2. Yes, yes. So, here what is oxidation state? 7 2s are 14 rather. 14 and that minus 2 extra. Oxygen 7 to the 14 plus 2 extra. Then based on this, in this oxidation state, from here, where is it going to? It is getting converted to Cr plus 3. Done. Now, if I take MnO4 minus stable oxidation state, it is going to Mn plus 2. Done. So, in this case, what is the configuration? D3 configuration. In this case, what is the configuration? D5 configuration. This is T2G stable. This is half-filled stability. Correct, na students? This is half-filled stability. Now, you only tell me. So, oxidation state is large. Change in oxidation state is large. Yes. So, the product or the order would be, remember, change in oxidation state is large means stability of the reduced products would be in this order. V3 less than chromium 3 less than manganese 2. So what is the oxidizing power order? So the oxidizing power order is VO plus 2, then Cr2O7 minus 2, then MnO4 minus. Check this carefully. Done. Careful. Remember. Next question. Give reasons. Mn plus 2 is a strong oxidizing agent. What is the reason? I said na. In the case 1, first important thing, Mn plus 2 is more stable. This is more stable. Why, students? Why it is more stable? Because, yes, it is reaching D5 configuration. So what will Mn plus 3 do? Mn plus 3 being a good oxidizing agent, it will go and take one electron, and something is accepting electrons, it is an oxidizing agent. So Mn plus 3 loses one electron and becomes Mn plus 2, which has D5 configuration. This is most stable. Done. Easy. Next question. E naught M plus 2 by M values are not regular for first row transition elements. Oh, what is this question? They said E naught M plus 2 by M values, the electrode potential values, are not regular. Okay, not regularities for D series. Why? What is the reason? So I told no, electrode potential means please try to explain in terms of first important thing, start writing like this. IE1 values and IE2 values, IE1 values and IE2 values, whatever are there, are less, relatively less. When I see this one, they are very relatively less in the table. Yes. For which one? For manganese and vanadium. Manganese and vanadium, when you check, they have almost similar values. Right? So, because of this irregular variations in the ionization enthalpies, right? So, automatically, yes, 3D series, that is first row of transition metals, that is nothing but manganese and vanadium. Because of this irregular variation in ionization 1 and 2, it is showing different. Right, this reason, this is enough. Third question is, although fluorine is more electronegative than oxygen, yes, let me see, oxygen, the highest oxygen, electronegative than oxygen, highest manganese fluoride is in Mn4, F4, whereas highest oxidation state is in Mn plus 2. Simple, students, they're asking, fluorine is more electronegative, but what is manganese doing? It is forming a bond with oxygen only in higher oxidation state. What is the reason? So how should I write the reason? Third reason, remember students, first of all, manganese can form which type of bonding? It can form p pi d pi bonds. Correct, no? With which one? With oxygen. Okay, done. So now what will happen? It is going to use 2p orbitals of oxygen and 3p orbitals of manganese. Both it is going to use. So because of this usage, it can show its oxidation state till +7. But in problem is what? Suppose if it is combining with oxygen. So that's why because of this plus 7, it is showing Mn2O7. Perfect. Now you see, this is with oxygen, with oxygen. Now same thing if I am trying to do with fluorine. What is the problem, students? In fluorine, it cannot form, cannot form p pi d pi bonding. P pi d pi. Why? Because the size is small. No, in fluorine the size is small. So only what is the maximum oxidation state? Maximum oxidation state is +4. That's, remember, that's why you're getting compounds as check. You're getting compounds like MnF4. Okay, MnF4 is possible. Mn2O7 is not possible. Mn2O7 is possible. Done. Next question. Yes, that's. These are the very, very important questions. Please subscribe to the channel, like the channel, share the video and comment. And all the best. Today I'm going to come back with one more video, very, very important video for exam. Please wait for me at 9 p.m. I'll send a video. So all the best, students. Please note the questions and share the video. Thank you so much.